to know. Thank you. Hello, how are you?
Just the second one.
Chris is doing his usual stuff, live streaming.
Okay, so he should be good here.
Yeah.
I'll make sure my,
Yeah, you're showing up there.
oh, excellent. Okay, good.
I haven't been to Saskatchewan.
I've muted my microphone. And I've got my reflection setting on for a second here. Okay. Oh no.
Let me know when you're ready to roll here, Chris.
We good? Right. All right, lights, camera, action. All right, looks like we're all seated and paying attention, which is good. Welcome everybody to the May meeting of the Ottawa Center of the RASC. And a special welcome to other RASC centers, members that are tuning in remotely. Welcome to our presentation. We hope you enjoy the evening. Let's see if this all works here after a week full of glitches. There we go. All right, so just a few reminders before we get rolling. We are recording this webinar for posterity, and it will be available at the ottawa.rasc.ca website. If you're tuning in with Zoom, you can use the Q&A function to ask a question of the speakers. And just a reminder that the chat box functions, the comments can be seen by everyone. Finally, the raise your hand function is disabled. We'd like to start off by acknowledging that the RASC Ottawa Centre acknowledges the trust placed in us by our First Nations with their ancestral lands and skies. And a quick agenda for tonight there. So I'm Paul Cloninger. I'm doing your introduction. Dave Chisholm will follow up with our outlook for the Ottawa skies for May, and hope you're bringing us some clear weather there too, Dave. Awesome. I love it. Then Bernie will give us a presentation that I want everybody to pay attention to, because it's going to be on green laser pointers. As many of you may have heard there, the rules regarding these devices have become a bit more stringent in the last while. And so Bernie is going to enlighten you on the safe use of those and other legal ramifications. Then Chuck O'Dale has a special trivia question. I love this, by the way, Chuck. That's A1. I think you're going to enjoy Chuck's trivia question. It's I've never heard of it, but I think it's real cool. Then we'll have a break, and Paul Cloninger, again, will give you a presentation on the enigma of Oumuamua, which some or all of you are probably familiar with. And for those who aren't, you will be after tonight. That'll be followed by various observation reports. Believe it or not, we have had a few clear nights, and so we do have some observations to share. Richard Taylor will then follow up with this coming month's monthly observing challenges, and I'll wrap up things with various announcements. All right, just wanted to extend a welcome to our new members in April. We're seeing quite a few numbers here. This is very encouraging, and so far we've had 50 new members join us just this year alone. So welcome to all new members. Hopefully some of you are in the audience and others are tuning in via Zoom. Welcome to our club, and I hope you'll enjoy your stay with us. We have lots to offer, and I think you'll be pleased. All right. That's me. Oh, I see. Okay. All right. Without further ado, Dave Chisholm with Ottawa Skies for May 2025.
So I'm hoping that April showers bring clear skies. Anyways, we can hope. Let's take a look at the moon phases for May. May the 12th is our full moon. It was known by our early Indigenous folks as the flower moon because it was the time of the year that spring flowers are coming out. It's also been known as the corn planting moon and the milk moon. And the new moon will be on May the 27th. We have the Eta Aquarids meteor shower, May 6th and 7th. Yeah, that's raining on Tuesday, isn't it? Okay. Anyways, that's why they're up there. It's an above average shower, approximately 60 meteors per hour at its peak. It occurs annually from April 19th to May 28th. It peaks the night of May 6th and 7th. So if it is rainy, just wait a day or two. You still will be able to see them. And these appear to radiate from the constellation Aquarius. As you can see, the days are getting longer. Well, the days are always the same length, but the daylight is getting longer. And so we have to stay up a little bit later to get our observing started. Mercury is now visible. It's rising and setting with the sun this month. Venus is at its greatest western elongation. So at sunrise, it's going to be at one of its highest points in the sky. And these are the rise and set times. For those of you who are not familiar with my slides, the first number is the first of the month, and the second number is the end of the month. Mars is visible in the evening sky. Jupiter is visible in the early evening. Saturn is now visible before sunrise. Uranus is visible in the early evening, first half of the month, after which it's more rising and setting with the sun. And Neptune's visible before sunrise. And there is our cartoon of the month. Thank you.
Thanks, Dave. That's awesome. All right. Up next, Bernie. On green laser appointments, there will be a test afterwards. So.
First, definitely test. Apologize for my whoever I just about sat on when I came in the dark. See what I was doing. All right, next slide, please, Chris. Like that. Big. Nope, that's backwards. Oh, big green one. I got you. All right. This is going to be more about laser pointers and lights in general. Green laser pointer is just something that stuck because most of the astronomical lasers that we use for doing shows and stuff like that just happen to be green, show up better. Transport Canada regulations. No person shall project or cause to be projected a directed bright light source into navigable space. By navigable space, anything above the ground is navigable. So you could interfere with someone's drone operation, helicopter operation, or whatever. So just be aware of that. And the fine for getting caught is extensive, up to $100,000. So, and they're talking about bright light sources here. So it could be a flashlight that has a very fine focus where if you're pointing at the horizon, you can see trees across the lake or something like that. Your light is a bright light source. The laser on this. Right? It's bright light, but you don't see the beam. Laser on this bad boy. You can see the beam. Both of these would qualify as a bright light source if directed at an aircraft. RASC has the authority under certain conditions to allow laser hand lasers for astronomy. There is a requirement by Transport Canada to have that training and to be trained. I'm the one that's doing it in Ottawa right now. There's a couple people in Kingston that took the course just recently. 5 milliwatt maximum power is authorized. That's what the laser I just showed you that had the beam on it. Anything less than that still has conditions, but we'll talk about that a little bit. It is prohibited by law to have a laser in your possession anywhere within the circles here that is over 1 milliwatt. On your laser, if you have one, if you're using it for lining up your scope and stuff like that at night, just be aware if it's over 1 milliwatt, you could be fined if you're in those circles. And those circles are just basically around any airport or certified helipad. There is training available, like I said earlier. It's about 2 hours to go through. I can do it through Zoom. Membership requirement is that you're a standing member for at least 1 year. I think maybe it was 2 years. Didn't write that down. Is it 2 years? Okay. A spotter and a user are required for a permit. So one person to use it and talks to the crowd, another person watching to make sure you're not shining the light anywhere near any aircraft. You can use, the spotter can use an app which allows tracking of major airlines, anybody that's got a flight plan, but you also have to watch out for the Cessnas and Pipers that are just doing line of sight flight. The event must be endorsed by RASC, and the process for that is an email to the council, and the council will approve it. For the event, the membership, the spotter and user both must have their membership card, written authorization, an insurance card which is available from RASC, and the maximum laser strength is a Class A or a Class 3A, 3R. 3R is the American sticker, and 5 milliwatt maximum. There's always a little sticker. Probably can't see it. I should have taken a picture of it on the laser, and it will designate on there that what the strength is. This one's actually no good because it doesn't say what the actual strength is. It just says less than 5,000 milliwatts. Good luck. That would say it's less than a 5 watt. If that's 5 watt, a 3A battery is not bad. So Transport Canada regulations state that no one shall use a laser or bright light source in a navigable airspace, and that anyone who is going to do so must be trained. RASC has the training authority in Canada for that. A permit must be given by the RASC center from the council. Event preparation is set up that you fill out the details. It'll be covered in training and stuff like that. But you fill out the details, get it signed off, and then afterwards you're ready to report to national. Safety and compliance, of course, if you're gonna do one of these shows, make sure that no one is shining in someone else's eyesight. It's also a benefit of having a spotter there, so if you're around, you know, have a second set of eyes to stop you. Were there any questions? Yep.
So one chart that you showed. Oh, we should use that. Thank you. Just wondering about the map. Yes, that map that you showed. It says prohibited to carry a laser greater than 1 milliwatt.
Yeah.
Does that mean like if it's in your pocket or in the dashboard or in the glove compartment of your car, and somebody comes by and looks for that, like that's prohibited as well,
That
even
is
though it's not being used?
It is prohibited to own it. I don't think anybody's actually been fined on actually having one. It's more of
It's
use.
possession of.
But it's if you're around an airport, especially like if you're walking around here where there's flight operations with a laser,
And have one in
Yeah.
your pocket. Yeah,
You
I can
probably-
see that.
you could probably get nailed for that. I don't know of any events or any circumstances where they have been caught. I know there has been a couple people in Toronto that have nailed for $50,000 each for actually using on an aircraft. So
Right.
they didn't get the maximum somehow, but I think they got lucky. I think they were underpowered for the laser. So
Oh, geez. And just in terms of the Transport Canada regulations, what do they stipulate in terms of specifics on use, or is it basically mirroring what you've outlined for us here?
I drew a lot of the information for the slide deck, which is really short, I guess, but just out of the training itself. So they have provided a letter of authority to RASC National to set up a program. And it says if you go to Transport Canada and do a search on lasers, it will point to RASC. So you
Okay.
refer to RASC. And we've called it green laser pointers, but obviously, you know, if you're using red laser and it's under 5 watt or 5 milliwatts, then you're gonna get it too as well.
So is that, would you advise that if somebody's going to, like, say, a star party and such, that they would have to have like a written document, or should they have a written document on hand just in case somebody queries them about this?
If you go to a laser show or a star party and someone has a laser, you should probably tell them that they can't use it, because as far as I know, I'm the only one trained in Ottawa. The trainings are good for 3 years, so they haven't done any training here for a while. I'm the only one trained in Ottawa, so if it's not me, then they shouldn't have a laser basically at a star party.
Very strict enforcement. Yeah. Very strict enforcement at the star parties. Okay.
Especially CARP's the
Right.
municipal airport, and no one there files a flight plan. They're all just up and
Up and
Yeah.
up and down. Yeah.
And in summertime, you'll see a lot of helicopter training and stuff like that there too. So they're really all over the place. I lived in CARP for 3 years, so saw it all the time.
Okay. Other question, Andrea?
I just have a question about this map. Where the red dots are, even if you had training, had a letter, had permission, those red dots, you cannot use it at all. Is that fair?
RASC has authority outside those red dots for permits. You can still do a light show inside those lines, but you have to get Transport Canada authority.
And that's not something that council really wants to do, right?
We wouldn't do it. We would tell the event organizer to do the paperwork, because if it's something they want to do, then they have to go to the mills to do it. I don't know how strict Transport Canada is. I know when you put in your grid reference and stuff like that, your lat and long where you're going to be, what the event is for, what you're using the laser for, whether or not you're in a flight line for the airports and stuff like that. Those are all considerations that they'll take into account when they're giving out the permit. I don't know of any circumstances here that they do that. I know Toronto does them, and Halifax as well. So
Is there a cost associated with the permits?
not that I'm aware of.
Okay. Anybody else? No? Okay, there will be a test. You won't be allowed to leave the auditorium until you write the test and then you pass it. And if you don't pass it, you're going to be here for a long, long time. All right. Thank you, Bernie.
Thanks.
That's super. All right. All right, International Astronomy Day. Is Jim here? He's online?
Yes, I am.
All right, there you are, Jim. Take it away.
All right. So, um, tomorrow is Astronomy Day. Yay.
No volume.
No, can you not hear me? Check, check. Mike's working on my end.
Jim, we got no volume from you.
No?
Either that or I'm going deaf.
Online hears me all right. It's the,
Keep talking, Jim, so that Chris can get
All
you your audio online.
so it's the gremlins we had the other day with trying to get Zoom audio in the auditorium. Testing, testing.
Jim, is your microphone connected?
Yeah.
We're not getting you at all.
Online it says they can hear me fine. So it's in the auditorium.
Okay. Similar problem to what we ran into before. Stand by, Jim. Do you want him to keep talking? Yeah, Jim, just, you can sing a song or, read us a passage from your favorite bedtime story.
All right. A horse walked into a bar. The bartender said, "Why the long face?"
Keep talking, Jim. Keep singing, Jim.
Check one, check one. Sibilance, sibilance. How's everybody doing today in TV land?
Ooh, that's loud. You better not cough into the mic.
Any luck yet?
Sorry, gang, just hang in with us for a minute or two. Keep talking, Jim. Keep singing.
Checking. Check one. Testing, testing. Hello, nurse.
Ah. All right.
Hello.
Hello. This is good now.
You can hear me all right now, Paul?
Yeah, loud and clear.
Okay. Step away from the microphone.
Go ahead.
All right. We're good to go?
Yep.
Excellent. Somebody write down a note to remember what setting to set for next time. Anyway, so tomorrow, Saturday, May 3rd, is Astronomy Day. I talked about this last month, how it's an opportunity for local amateurs to get out into the public and share their love of astronomy with the general public, basically. So there was some humming and hawing about weather. We're not going to have great conditions, but the probability of clear skies in the evening is best on Saturday. So we are a go for a Saturday. Go to the next slide, please, Chris. So yeah, there's some pictures of past events. That gives you a general idea of what to expect. We're set up in the parking lot next to Chapper's Bookstore at Silver City. Next slide, please. The official time of the event is from 10 a.m. to 10 p.m. A number of us will be showing up more like 8 o'clock in the morning to start setting things up. You are welcome to join us whenever you're available. The address is 2401 City Park Drive. And we are still happy to receive new volunteers. Right now we have about 25 people who have said they're going to come with telescopes, including myself. But we're always happy to have other people come. And in fact, if you are a new person to astronomy and have a telescope that you'd like some help with, coming during the day when it's slower, it would be an excellent time to do that. Our volunteers would be happy to help you out. If you have any questions, you can contact me at the email there on the screen, or just come and talk to me tomorrow. Thank you.
Well, thank you, Jim. And sorry about the problems at our end here, but
No problem.
we heard you. And I just wanted to add a piece of information that I actually just became aware of like 2 minutes before the meeting. Apparently, this is the 25th anniversary of doing the Astronomy Day event at the chapter's Silver City. So
That's correct, yes.
congratulations to all of those folks that have contributed to that on a voluntary basis. And for those of you that haven't ever been to the event, it's an interesting opportunity just to come by and see all the wonderful pieces of gear out there and chat with people about what they've got and what they do. And hopefully we'll all cross our fingers for you, and hopefully we'll get some clear skies. Thanks again, Jim.
Great. Thank you. See you tomorrow.
Good. I don't think that was me. You good? Okay. Andrea's going to follow up here.
Here again, asking for volunteers again. This is my thing. Also, are there new members here today? Hi, nice to meet you. Happy to chat at the break about how you can learn more about our society. And honestly, Astronomy Day is so fun. Come early. We have solar scopes. You'll have a great time. So as part of our partnership here with CASM, they let us use this beautiful theater. We provide outreach help for them. We have agreed to provide a solar outreach day, May 24 or 25, depending on the weather. And also Canada Day, we will be here. Usually it's just solar observing. Canada Day, they really hope that we would do it rain or shine. So if it is cloudy and we can't do solar, we will try to do an activity inside. We also are hoping to have as many Anglophone and Francophone members attend, because bilingualism at these events is very, very important to our society and for CASM. So if you can help on any of these days, that would be great. And while I have the floor, I am going to mention that Rick Scholes, who is the director at Flow, told me that he's sending out an email that on Sunday, so today's May 2nd, tomorrow, May 3rd, is Astronomy Day. You're all going to go to Astronomy Day. And then May 4th, he's having a daytime Flow orientation. FLO is our club observatory. I loved it when he did it during the day. You get to see where everything is. And so when you decide to come at night, it's not so confusing. So if you are a new member, I strongly encourage you to go to the daytime orientation. Rick sent an email, just let him know you're coming. I haven't actually read the email, so I'm not sure what time it is, but I'll be back at this mic, so I'll try to find that out by then. Sorry? Is it Star Wars Day? Oh, yes, that's why he did it. Excellent. May the force be with you.
Couldn't resist, sorry. Thank you, Andrea. So for those that weren't paying attention, note that this is not Astronomy Day tomorrow. This is on the 24th and 25th. All right, and July 1st. All right. Let's see what we have. All right, Chuck. Chuck has a really interesting trivia question for you all. You're more than welcome.
So the big green arrow, eh?
Yes,
That's, which one? This one?
the big one.
Right
Right in
there.
the center there.
Oh,
Yeah.
that guy. Okay. Hi, I'm Chuck Waddell. I used to do this a long, long time ago. Actually, I did the trivia questions before the time of Google, and I tried to make them as difficult as possible. And I actually had prizes for anybody that won it, some of the shatter cones I had. And every once in a while, somebody did get it. But then Google came out and poof, they spoiled everything on me. So that being said, Paul said this is a kind of a cool one. I think this is Google proof. You guys can Google it if you want, no problem at all. I actually got on the computer and searched for it, and I actually made Siri cry because she couldn't find the answer. So this all starts off with, I'll run through a few things here. Voyager 1, back in 1977. This was, to me, was awesome because back then I had my 6-inch telescope and 30-degree below weather looking at the Orion Nebula. We've all done that before. So this is what, oh, I have to go back. I want to go back. Can I go back on this? Oh, that's okay. Yeah, it's 77. I just want you to note the year 1977. It's kind of important, just as a thought. So that's the robot. It's still out there. It's still functioning. It's just an awesome piece of equipment. It just blew me away when it happened. And of course, we looked at every second of the way. We made sure this thing was flying. And Jupiter, again, I remember with my 6-inch telescope looking at Jupiter, and every once in a while, for a millisecond, you can see the stripes on Jupiter. It was just so cool. And then, of course, Voyager come out, and these images just blew me away. And then, of course, to Saturn. And with my telescope, I just love watching little kids when they first see the rings. That's kind of cool. You know, when they see that ring, they go, wow. I still do, actually. Anyway, Saturn was kind of important for Voyager because Voyager didn't use its correction thrusters since Saturn all the way till 2017 when they had to redo something with it. Just a part of the trivia part of it here. So Voyager zoomed through the solar system. There she is, way, 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 way out there. Now she's going at about 17 kilometers a second. That's about the speed where, if you look at my old website, I've shown you a whole bunch of craters and that. We're going to explore one pretty soon. These bolides hit at the minimum of 17 kilometers a second, and sometimes up to 70 kilometers a second. But they make some pretty cool holes, and I spent many, many years exploring them. But at 17 kilometers a second, poor Voyager will take them 74,000 years to get to the nearest star. Actually, the second nearest star. Now, there's something in my public school. I got an examination question wrong, and I'm still pissed off about it. The question was, what's the nearest star? And of course, I said approximately. And of course, it was a trick question, but I really meant it. Anyway, so this thing, Voyager is zooming away 17 kilometers a second out there in outer space. So it is out there, what, 25 billion kilometers away. It is NASA's furthest human-made object from Earth. Or is it? This is what I'm getting to. Sometime there is a hypothesis that there is another man-made object farther away from us than both of the Voyagers. Just think about that for a second. What did we do to get something out there? So what is it? How did it get there? Answer after the break.
That's great. I didn't try to Google that, Chuck. And I'm sure people are already pressing buttons and either at home or here in the dark to find an answer. But that's for those of you that aren't Googling and have no clue as to what it is. I think you'll find this really interesting when Chuck gets back to us after the break. Thank you, Chuck. All right. Oh, we have no announcements. Okay, so we'll go for a bit of an early bio break. Just a reminder that the museum is closed. We actually have good time today. Why don't we extend the break and let's make it 15 minutes and you get a chance to chat with folks and stretch your legs, and we'll be back in 15 minutes. Thank you.
The guys, I didn't say, okay, well, point is unmoved. It's not gonna be super accurate, but then you can just find what you get that. You've got a probably. And then you could do, you'll have a finder scope, a red dot finder scope or something like that. So one of the key things you have to do is have to find that finder scope in the center of the image. Like that today, I looked at and I looked at the IP. And then look through the red dot star finder and I this one here, one here. As soon as it aligns with that, then I'm ready to go. Then at night I could say, okay, there's Saturday. I look through the star finder. Back to the Stick with the ones, right now. Oh, okay. Okay, and then what you do is you can borrow when you start party, or somebody else's life. So I'm gonna be out there tomorrow. I'm going to go on. I may or may not have my house go out. We'll see it. It's on a tripod. Great. Nice meeting you. So you're retired.
Great job.
That's pretty cool, yeah.
It is very cool. All right, we're about to resume. Hope you enjoyed your break. And if we can have our lights back. Let's see. All right. So we'll start off with Chuck's answer to his most interesting question, and then I'll have some announcements.
Yeah,
Right,
as I mentioned, I made Siri cry. I think she's still crying. She's probably crying now that 5 people here knew the answer. That is awesome. Yeah, way. We had 2 people on the web. Thank you. And 3 guys here. Awesome. So what was going on here, he says. Okay, well, back in the 1950s, lots of crazy things happened. Of course, these things were blasting away all over the place. And some bright young spark said, let's put these things underground. So they dug this borehole, and the first test they did, there must have been a kilometer-long flame that came out of the thing. So they said, well, that's not doing quite nicely. So let's put a cover on it. So they put a couple of 900 kilogram steel plate cap over this thing, blasted another one, and nobody could find the cap. Nobody knew where it went. So, they put this high-speed camera. So this was a result of the one test. So basically what they did, they put a high-speed camera over the borehole cap at 1 frame every millisecond. And let's see what happens. Well, at the explosion, the steel plate cap only appeared for 1 single frame. So from that, you have to estimate the velocity. So they figured, well, it's greater than 66 kilometers a second. And to give you a background, from the Earth, it's 11.86 kilometers approximately. And again, a little bit of aside, I digress for a second. I'm a bolide meteorite crater guy. And if one of these big things hits the atmosphere 100 kilometers up, so you're looking at least, say, 11, 14 kilometers a second. So you're going to see something bright, count to 10, and boom. So it won't hurt, don't worry about it. And finally, the escape velocity from the Earth's orbit is about 42.1 kilometers a second. So at 66 kilometers a second, this thing was flying. So we figure somewhere out past Voyager 1, there's this radioactive steel metal plate that's further away than both the Voyagers. And 5 people knew about it, so that's cool. But the escape is here, it may have burned up going through the atmosphere. Going that fast, we know that bolides have a hard time getting through the atmosphere sometimes. Anything bigger than a school bus will probably make it through. But going out at 900 kilometers or 900 kilograms at over 60 kilometers a second, it may have burned up pretty quick. So that is the answer to that. 5 people, congratulations. I'm not giving prizes away. But the good part is, all we have to do now is have a whole bunch of these atomic cannons around the planet, and we can defend ourselves against the Borg when they show up. But I digress. Here's a question. It's not a trivia question. It's a question for everybody, and I don't know the answer, but I wish somebody could study this a bit better. You get atomic blasts, they have these large electromagnetic pulses. Now, if they can be detected in our galaxy, that would say that this civilization has discovered atomic weapons. So that would show that, yeah, there's life out there and maybe sort of intelligent life to make atomic weapons. But to my knowledge, nobody has studied how far an EMP can be detected from our planet, because I know there's a bunch of them out there flying away right now. So somebody out there listening to these things will say, oh, stay away from this planet. Yeah. Anyway, it could reveal, that's just my digress there. And I'll digress again, since we're on a Cold War theme. If you're ever out by the Defen bunker on Sunday afternoon, I volunteer out there in the in the emergency radio room, and I give a long dissertation of the electronic communication of the Diefenbunker during the Cold War. And I was stationed there at one time during the Cold War. It was kind of cool to talk to people about that. And a few other people I've talked to have been in there. So Sunday afternoons, if you're there, come on in and have a chat. And finally, I digress again. A while ago, Andrea posted this beautiful picture of the solar partial eclipse on the website. And we're looking through it, and Jillian said, that's our boat, isn't it? Yeah. So actually, that's Jillian and I just enjoying life to the fullest while this thing is going on. And thanks, Andrea, for getting our boat. Thanks, Bob.
It's great, Chuck. I love the defense against the Borg. Kind of reminds me of for those of you that are Star Wars fans, the ion cannon they used to blast a clear pathway, clear out a few Star Destroyers. Anyway, steel plate ought to do it too. I wouldn't want to get smacked by a 900-kilogram steel plate traveling at 66 clicks a second. That'd be a bad hair day. And I hadn't got any to spare. All right. All right, so just a few of my standard messages for those of you tuning in and for those of you that may be in the audience that have decided to take us up on our offer of free attendance to our meetings. Should you choose to become a member, there are many benefits to the membership in our club. We have, as you may have gathered by now, a bunch of interesting people with interesting stories to tell. It's a great opportunity to connect with folks of similar interest at our club. We also have the Ted Bean Loan Library, which is a telescope loan library. We have numerous instruments available that we lend out to members. I was actually just talking to somebody today about who was contemplating getting into photography and stuff. Having access to a scope before you buy it is a nice thing. Try before you buy, as it were, because they can be expensive depending on what you wind up getting, and they take a little bit of getting used to use them properly. So great opportunity to try your hand at things, and all it costs is your time. So that is available to our RASC members. You can also earn RASC observer certificates from the club. And yeah, we have a whole list of those different types of observations for different levels of interest. We also have the Stan Mott book library. Estelle, are you here today? Oh, there you are. I should know, you're always sitting down in that part. So Estelle is our club librarian and guardian of the books there. And so if you are interested in finding out what we have in the library and signing out a book, please talk to Estelle, and she will be available for a bit after the meeting. Yep. Okay. Super. All right. In addition, your membership also gets you some publications. We have the Observer's Handbook, which is a renowned publication that's been around for decades and is used worldwide. It's a wonderful handheld reference of all sorts of astronomical data going month by month, and also looking at specifics on eclipses and meteor showers. Really handy for those times where you're out in the bush somewhere and you don't have an internet connection. I find it easier sometimes to ferret out the data I want there rather than pulling my hair out trying to get an internet connection. So very, very useful publication, comes out annually. You also have access to the journal, which is the publication of the society, and tends to be a bit more technical in the articles. And on a monthly basis, we also have our astronauts going ons in the club there, and photographs submitted by members. So just news of the club, and a handy little reference to have. So those are all benefits of your membership. You also get access to the Discord server, which is open only to our members there. So it's again, it's an online chat space that you can connect with folks and ask them about or converse with them about astronomical interests. You also have access to Astrospheric Pro, which is an interesting application. There's a free version of this, which anybody can download. And basically it summarizes weather conditions. It's similar in some ways to the, excuse me, to the clear sky chart. But it provides a lot of different levels of information, especially at the pro level. But the pro level, if you're not a member here, that costs you $66 per annum. That is free with your membership here in the club. Yeah, so we have a number of members of the club already on that system, and again, that is available to you. So in terms of the membership, regular membership is currently $113 a year. Family membership is $107.50, plus only an additional $15 or $9 for like an additional adult or a youth. And we also have a student rate posted, as you can see. All right. I guess that's me. All right, so I've got prepared a bit of an interesting, what I find interesting discussion about an object that appeared in near Earth space a number of years ago. Many of you have probably heard of this, and for those of you that haven't, I'm going to give a bit of a background here. So Oumuamua is an object that was detected coming into our solar system back in 2017. And it is an odd little object, and it is little. This image that you see here was taken by the 4.2 meter William Herschel telescope in the Canary Islands. And it's one of the best pictures that we have of it. It's that dot in the center. So this is a small object, and it was only recorded about 5 days after making its closest approach to Earth. It's sort of caught people by surprise, and it became an interesting object of study. It was actually discovered by the Pan-STARRS 1 telescope in Hawaii on October the 19th in 2017. And as I said, this is like 5 days after its closest approach to Earth. And it came to within 24 million kilometers of the Earth. That's only about 60 times the distance from the Earth to the Moon. So the reason that this was interesting is we scrambled to make as many observations as we could to try to learn something about this, because it was seen to be moving really fast. Is that me? Oh. It was seen to be moving very fast. In fact, its orbital parameters were calculated, and it soon became really apparent that this thing wasn't from our solar system. This thing was moving on a hyperbolic trajectory, which to get past the technical jargon, is the type of trajectory you would expect for something coming into the solar system from outside and traveling at a good speed. This is the fastest thing that we've seen in the solar system, bar none, maybe except for Chuck's 900 kilogram plate there. I think the plate was moving even faster than this puppy, but it was seen to be coming in very fast, coming in from well above the plane of the orbits of the planets. And so we ran the calculations, and I used the term hyperbolic trajectory. That indicates an open-ended path. And what I mean by that is, when we look at the planets, they all have none of the planets are in perfectly circular orbit. For a perfect circle has an eccentricity of 0. It is a perfect circle all the way around. Earth has an almost circular orbit. It's very close. Has just a little bit of an eccentricity above 0. And comets, and that's true for all the planets in the system. Comets, on the other hand, that we see periodically coming in, especially from the deeper reaches of the solar system, the the Kuiper belt or even objects that are a bit closer towards the edge of the orbital paths of planets have a very elliptical orbit. But their eccentricity is given a value between 0 and 1. Can't be greater than 1 there. If it's greater than 1, it's open-ended. And so even as you see from this chart, even comets within the solar system that have very elongated orbits, like Halley's Comet, for instance, have an eccentricity less than 1. This thing, when it was coming through, it was measured to have an eccentricity of 1.2, which tells you that it didn't come from within the solar system. It had to be coming in from outside, and it was coming in with some serious speed. As I mentioned, faster than anything else that we've seen in the solar system. Just to give you an idea, this is the path that it followed on its journey. And there we go. It's just repeating itself. So you can see it's coming in from on high, zoomed in, looped around the sun, and because of the sun's gravity, had its trajectory bent substantially, and then it rocked on its way out towards the outer solar system again. It's moving very quickly. So one of the things that was interesting about this, we quickly determined that this had to be an object that entered the solar system from somewhere out in interstellar space. We've never seen anything like this. This is the first recorded object of its kind, something that we know didn't originate in our solar system. But we started observing a couple of interesting things about it, including its light curve. As you can see here, this is a plot of its curve taken with a number of different telescopes as the Earth rotated. Not one single telescope would have a continuous view of it. So we used a number of different telescopes to try to calculate its light curve, in other words, how bright it was, and if there was any variation. This thing is small. It's as I say, and I'll get into the details of its size here in a moment. But what the light curves indicated is that it had a regular variation in its brightness. And when we model this against what we would expect for different shapes of objects, we saw that it looks like the object must have been an elongated object, 10 times longer than it was wide or thick. And again, even with our most powerful telescopes, as soon as we started observing this thing with some of those telescopes, it was only a pixel because it's small. We determined that its size was on the order of, and there's still a lot of variation because we have a limited amount of data. This thing didn't give us a lot of time to observe and finesse some of the fine details. But its size was only estimated at somewhere between 100 meters to 1,000 meters, so a kilometer. So asteroid size, basically, or comet nucleus size. But it had this unusual light curve that was repetitive and seemed to follow the what you would expect of a long elongated object tumbling. So what is this thing? Artist conception. It didn't display any outgassing as you would expect if this was a comet coming in from interstellar space somewhere from another system. But if it was a comet, you would expect to see a level of outgassing, especially since we only observed it about 40 days after it rounded the sun. And this thing came really close to the sun. I mean, it was within the orbit of Mercury. So it got toasted, it got warmed up. And if it had been a comet, for those of you that are familiar with comets, we get sun grazers and things like that all the time that get pretty close to the sun, and they either fracture or they survive their passage and sometimes light up the sky, like some of the comets that we've had recently. This thing displayed none of that. It displayed no signs of outgassing, no tail. So people were convinced that it is some sort of an asteroid. But it had some anomalies associated with it. It seemed to be about 10 times more reflective of the light, given its distance and assumed size, than you would expect from an asteroid. It had a reddish color to it, which is what you would expect from an asteroid that's been circling around for a long time in space. They tend to get reddened because of a cosmic ray bombardment on the materials on their surface. So it seemed to have that characteristic, but it seemed to be rotating as well as tumbling with that period that I showed you. And again, there was no signs of any outgassing. There are some estimates too. Again, we had very little data to work with on the modeling. Some estimates thought instead of a cigar shape, a certain amount or certain degree of tumbling and motion could also lead it to be some sort of pancake shape, like a disc shape. I won't use the word saucer here, but keep that in mind anyway. So again, we weren't able to resolve anything more than a pixel with this thing, and so we're going on a very limited amount of data, which was still useful to us because it allowed us to do accurate estimates of its trajectory, of its velocity, even its composition to a degree. Yeah, and we'll leave the saucer for now. So this is another animation showing what this elongated object looked like and its tumbling motion that some of the models indicated that it had as it approached to within the solar system. This discovery, it just generated a huge wave of interest and speculation in the astronomical community. The possibilities here that we were actually seeing a body from another star system passing through our own solar system was very intriguing and certainly a unique learning opportunity. And it raised a lot of questions, but there were more questions to come. And as I say, it was moving very quickly. So we had a matter of really only a very short time in terms of like a week or two of opportunity where we could train some of the bigger scopes on it if they were facing it at the right time and stuff to glean any kind of data from it. But that was enough to reveal something really unexpected about this object. So what we have is an anomaly that occurred here. We watched this thing after it passed by Earth, and we watched it on its trajectory, and we noticed that it wasn't following the trajectory that it should have been if it was just a dead asteroid rock type of thing, following just orbital mechanics based on its inbound trajectory, based on the gravitational attraction of the sun and its outward bound trajectory. We could calculate that to a pretty fine degree of accuracy, but when we ran the calculations and compared them to the actual observed values, we found a discrepancy here, which really left a lot of people scratching their heads. What it was that this thing actually picked up velocity as it was heading out of the system. So what you would expect for an object like this is after it rounds the sun, where it's picking up a lot of velocity, whips around the sun and then heads out. The sun is still tugging on this thing all the while it's heading out, so it tends to slow down. And we can measure that rate pretty precisely. And what we found is that it was actually speeding up a bit and had its trajectory, and as a result, its trajectory was deflected somewhat. But again, we observed this thing for as long as we could with the biggest scopes that we had. We saw no evidence of outgassing, which was a prominent theory put out to explain this acceleration. As you can imagine, if it was a comet-like body, this thing's just been baked from the sun, its close passage to the sun, and you've all, for those of you that seen comets, you know, they can put out a lot of material. They can put out, you know, gas vaporizing off the surface. That also tends to lead to little bits and pieces of matter, as well as the gas being ejected, dust fragments and such that were frozen into the comet's surface that are now freed because of the heating that it's received from the sun. And so the comet, when it follows its path, even though it's heading out into the outer reaches of the solar system, expels a lot of this stuff, and they're actually known to be able to give a body like a comet a little bit of a boost in its velocity. So they can speed up a little bit more than you would expect if it was just an inert solid chunk of rock. So this was a theory that was looked at pretty heavily, but again, we found no evidence of gas or dust being expelled by this object as it was heading out of the system. All we see was this anomalous increase in its speed and somewhat of a deflection in its trajectory. So it begs the question, what really is this thing? What actually might it be? Something that looks like an asteroid, smells like an asteroid, walks like an asteroid, but is also speeding up. It doesn't behave exactly like an asteroid, nor does it behave exactly like a comet. So maybe something in between. Certainly there are a lot of theories about this. Some of them wilder than others. If you've got a lot of time to kill, just Google the internet on the origins of Oumuamua, and you'll get some pretty wild stuff. So why do we know that it wasn't a comet? As I mentioned, it didn't have a gas tail. It didn't release any dust. And as it happened, 2 years after Oumuamua's closest approach, we actually had only the second known interstellar object entering our solar system, and that was Comet Borisov in September of 2019. And unlike Oumuamua, even though this was a very faint object, it was still big enough. This is a time lapse that I took with my 11-inch telescope of an interstellar comet. I was so thrilled to get this, even though it's just a little smudge ball here. But you can actually see the motion over a span of a couple of hours here. And so it was visible. It had a tail to it. It was expelling dust. It was behaving exactly like a comet should behave, except that, like Oumuamua, it was on a hyperbolic trajectory. So we know that this comet wasn't one of ours. It didn't come in from the Oort cloud or the Kuiper belt, unless it got somehow whacked by a serious collision there. But even that, I don't think would have given enough speed to follow the trajectory that it had. It was on a hyperbolic trajectory, not quite as hyperbolic as Oumuamua, but hyperbolic nevertheless, which means it's come in from the outside, circles around the sun, and then leaves and never to be seen again. So Borisov was interesting. And again, unlike Oumuamua, we saw this coming early, and we could train some of our best telescopes on it. This is an image taken by the Hubble Space Telescope, and sure looks like a comet to me. There's really no doubt about this. And so again, this was an interesting object of study for something that we knew came in from outside our solar system. And because it had a lot of similarities to the comets that we all know and love that are local relatively, we can surmise that whatever system it came from, and God knows how long this thing has been flying around in space, but it's not made of anything more exotic or unusual or such than the comets that we know of that roam in our solar system. So that's the result we expected. And again, as it looped out, it still had its tail. We could measure it as far as we could, as far as those telescopes allowed. This pretty faint object there, when I photographed it with my with my 11-inch telescope, it was already down to a magnitude of 17.5. So for those of you that do astrophotography and such, you know that that's pretty dim. But it was visible, and it wasn't just a point. It wasn't just a pixel there. It was a comet. All right. So what have we learned about Oumuamua? Well, the exact origin of this object is a mystery. There have been a lot of studies by obviously groups that are involved in doing this because it was such a unique opportunity. We wanted to figure out, okay, we have a handle on its trajectory, both inbound, well, not so much inbound because we only saw it after it rounded the sun and passed the Earth. But we have a pretty good handle on its trajectory, and we can work the math backwards. And also we couple that with our models of how the galaxy moves and how neighboring stars move along with our sun. And so people have run those calculations with supercomputers, some of them, to figure out what stars possibly could Oumuamua have come from that are in the local vicinity. Came up with, I think, 4 different candidates that were possible. But again, our knowledge, when we get out to that level of distance from our own planetary system, we start to get error bars in there. And one of the most promising objects that could have been in its trajectory inbound, it passed. It probably passed fairly close to this one star. It has this long string of a name, just a name and a number, really. But it was determined that even if it came from that system, it was traveling too fast. So it would have done the same thing that it did here. It would have passed through that system on a hyperbolic trajectory and had its course bent. And it basically wound up heading for us some million years later. As Chuck mentioned, the Voyager probes traveling at the speed they have require on the order of, I think, what did you say, Chuck? 74,000 years? 74,000 years to get from our system to Proxima Centauri, the next nearest star to us from our sun. So it begs the question, this thing has probably been traveling more than likely for millions, if not hundreds of millions of years, just wandering interstellar space within our galaxy. That also has a lot of ramifications in terms of trying to figure out its composition and stuff, because that length of time in bare space where you're not under the shield of a heliopause, for instance, like we have around our solar system, courtesy the sun, you're exposed to the full blast of whatever cosmic rays and stuff will hit that object, as well as whatever particles it'll intercept as it's whipping through space on its trajectory. So we're really not certain about its origin there. We have rough ideas where it came from. It came roughly from the direction of Vega, although it wouldn't have come from Vega. Vega wouldn't have been at that point when it was that far away from us. It wouldn't have been at that point at that time. So it really is an unknown, and we think that likely its reddish color was, if it is asteroidal in nature, it was probably due to just bombardment by cosmic rays over tens or even hundreds of millions of years. But again, that's speculation. What we don't think is, well, actually, let me rewind a little bit. Some of the theories that have come forth for this is that one of the things we've come to learn because of the magnificent telescopes that we have nowadays is that what our studies of exoplanets, planets around other stars, has given us is information that our theories about planetary formation, which we've had good theories for many decades, but it's really only been in the last few decades where the instruments have become powerful enough to detect things like accretion disks around newborn stars, where planetary systems might be evolving. Those theories have been given a lot of credence, and with the observations, and so certainly one of the leading theories for this object is that it was probably an asteroidal type of object ejected from whatever system it actually was born in. And that's not hard to believe when you look at this artist's illustration. When the planets are young, when they're in the process of just forming, there are a lot of collisions. In fact, I think my next slide shows some of that stuff. There's a lot of collisions in that accretion disk that planets fragments start to come together, they start growing, but then they smack into other like-sized planets fragments, and they shatter again. And so it's an ongoing process over many, many millions of years until the planets accrete into the form that we have. Earth, for instance, is a lottery winner, if I can put it that way. Certainly, as our solar system was in its very early years, there were a lot of planetesimals, some as big as the Earth, some smaller, but there were a lot of collisions, things smashed into each other, reassembled, and all the while, things were getting either swallowed up as becoming part of larger objects, or they interacted gravitationally with some of those and got chucked out of the system altogether. So we have in those early days a very crowded space around a star that would certainly enable the ejection of material with enough velocity to escape the gravitational pull of the star around which they are orbiting, especially if we're looking at objects out like as part of, for instance, again, if I use our own solar system as a reference, when we're looking at the Kuiper belt, for instance, it was that zone beyond the orbit of Neptune, where we know a lot of these smaller planetoids, dwarf planets, reside. Gravitational attraction of the sun is far less than when you're on the inner part of the solar system, like here on Earth, or even closer to the sun. So it's conceivable that some of those collisions would have whacked things right out of the system, only to have them wander away, escape their star's gravity, and just wander interstellar space until they encounter something that changes their course or deflects their path. So that is certainly a leading theory, and I mean, there are difficulties with that theory in terms of we know this thing accelerated, so if it was something natural, there had to be some sort of outgassing or even something that caught enough pressure from the illumination of the sun, like a solar sail, to give this thing this push in velocity that we know happened to it. And a solar sail was actually one of the theories that was put out by an eminent astronomer, Avi Loeb, to explain what this is. He was a proponent of a theory that this wasn't the natural object. This was something that somebody built, like a light sail, and essentially was a probe that just wandered from system to system, investigating it. Again, there's a lot of stuff out there. Most people in the scientific community don't believe that was the nature of it. But hey, it's a big universe, and who knows, anything is possible. It also, this object may have been something that fractured a little closer in, either in a more mature planetary system, where we have perhaps binary stars, for instance. Those complicate the matter of gravity greatly. When you get two stars revolving around each other, or a trinary system, the gravitational perturbations on bodies orbiting those three stars can start to become pretty complicated. And so again, one of the hypotheses is that maybe this was in a more mature system. It was an asteroidal-like body that fractured either due to it approaching too close to a large planet, a Jupiter-sized planet, for instance, or even its own star that it was orbiting around. And it fractured and again was given a kick out of the system. It is possible. I mean, theoretically, that type of origin is possible. One of the things we don't think, as I mentioned, is that it was an alien star cruiser. But who knows, right? I mean, that's an interesting theory, but again, not widely believed by the astronomical community. But I'll have a couple of comments on that in a moment. So I've mentioned some of the theories. Some theories speculated that might have actually been an object from the very outer reaches of our system, where the sun's gravity isn't very strong, certainly a lot less strong than it is on the inner part. And so maybe just the right interaction of two bodies colliding out in the Oort cloud or in the Kuiper belt sent one of these things in and one of these things out, fragments in and out, depending on their orientation and the amount of energy they received. But it's questionable whether an interaction like that would have kicked an object with enough velocity so that it escapes the system. So we're left with the thought is it from actually our system? The problem with that is when we run the numbers on that, we know that what the inbound velocity was and the outbound velocity. If it was something that was locked to our system, generally speaking, most of the calculations would show you that it's not a hyperbolic trajectory that this fragment, this inbound fragment assumes. It's just highly elliptical, and it will return roughly to the same distance from the sun as it started out to, roughly speaking. But it won't, generally speaking, again, have enough velocity to get kicked out of the system completely. A lot of simulations depends on a lot of stuff like the mass of the object, how hard it gets hit, what's left of it after the impact. So again, rather speculative. All right. So the other thing is its composition. Again, we only were able to image a dot, basically, even on our most powerful telescopes and cameras. So it begged the question: was this thing a rock? Was it a chunk of metal? You might think, well, metal. How's that happen, right? But we know that some of the asteroids that we see, even in our own system, contain a high proportion of metals in them because they were probably formed in the cores of one of these early planetesimals that later smacked into another one and threw out all sorts of different fragments in different directions. But if this planetesimal had formed large enough, it may have had a molten or semi-molten core. And if that's the case, you would expect more metals on the interior of that object. If it got totally shattered, any chunk from the interior would be metal rich. It's very plausible. The hypothesis that it is either a metal or a rocky asteroid holds up much better than a comet, just because again what we observed in the lack of any emanations from it in terms of dust emissions or gas emissions, and the surface color, as I mentioned, is roughly what we would expect from an asteroid that's been exposed for a long term. Although again, it was a lot shinier than what we would have expected. Again, no volatile materials. The rotation of this thing is also complicated. You run a lot of these models and see what falls out of them, what you get from them. This thing is believed to not only have been rotating, but tumbling. So a very kind of a complex motion, as you saw in one of the animations there, of its motion. And it's kind of hard to imagine how its specific motion, if our numbers are right on this, would have come about through just a random collision of some sort. Not impossible, but difficult to imagine how it might have come across. And so, yeah, there was also a recent paper put out saying that this might have been what we call a fossilized comet. In other words, yeah, it came from another star system, but it started out life as a comet, but it may have formed a crust over it that protected the volatile elements within it. And so we saw no outgassing and no tail generation. There's also some speculation that it might have been a big chunk of basically a chunk from an exoplanet rich in nitrogen. And so basically like something similar to Pluto, which we believe is of that composition, and then fractured, and that frozen nitrogen ice wouldn't, I suppose, with a crust, be as susceptible to the erosions that occur in interplanetary and interstellar space. So again, a lot of speculation. Unfortunately, we just didn't have a lot of time to study this thing, so there are a lot of error bars in some of our assumptions. Other than its trajectory, we know that it followed an anomalous trajectory. All right. So fast forward, Project Lyra. This is an interesting thing. This group formed the Initiative for Interstellar Studies, begun putting out thoughts of how we actually might visit this thing. This thing is barreling out of the solar system, again, faster than Voyager, or again, maybe not as much as Chuck's steel plate, but it's moving. And so it's already out by beyond the orbit of Neptune. And that's in 6 years. So it's booting along. So initially the thought of sending a spacecraft out to check this thing out was, oh yeah, we can't do that. We don't have the technology. As it turns out, a lot of clever number crunching people with access to very nice, fast, powerful computers ran a number of simulations and said, wait a minute, we could actually do this. We could actually send a probe still now out and reach this thing in a reasonable number of years. So they kept running simulations and proposals, and they continued to do so. So one of the things they calculated was that if we launched a spacecraft from Earth and used multiple planet flybys, and we've done this before, we actually have this down to a pretty good art, because we've this is how Pluto, for instance, managed to be visited by the New Horizons spacecraft. It got a gravitational assist from its final one from Jupiter, which gave it a real acceleration at speed and was able to go out. But it still took 10 years almost 10 years to get out to Pluto. But it worked. It worked beautifully, and actually visited a Kuiper Belt object some years afterwards. And it was, powered by a radiogenic generator. So it still had the power. And so we got two flybys for the price of one. They calculated that if you can see the sequence here, we launched from Earth in 2030 with this spacecraft. It does a deep space maneuver to shape the orbit in a very precise way. Does basically sending it back to Earth, the vicinity of Earth, where it picks up more speed by doing a gravitational assist around the Earth. Then heads out to Jupiter from that assist, arrives there 4 years after launch, excuse me, and then uses Jupiter's gravity to then actually bend it back into the solar system, where it then does a flyby within 6 solar radiuses of the sun. So basically, it's kind of mimicking almost the trajectory of Oumuamua, although Oumuamua didn't get that close. But this spacecraft would get very close to the sun, pick up an enormous amount of speed, and then get booted out into the system, where we could rendezvous with Oumuamua in 2052. So a pretty good long coasting time, where basically it's not going to encounter anything. But again, that was the case with New Horizons when we shot it out to Pluto. It was virtually dormant for most of its journey, saving its power and such. And then it was programmed to wake up when it got into the vicinity of Pluto for showtime. So that was one possible trajectory, but we ran the numbers on this, given the current state of the rockets that we have, the strength of the boosters, and available timelines. And what we found is that this thing would need a substantial heat shield. Getting that close to the sun, 6 solar radii, I mean, it's going to be baking. But for those of you that keep a tab on explorations within our solar system, you know that the Parker Solar Probe has actually done this. We actually developed a sufficient heat shield to allow it to fly very close to the sun, and closer than anything else that we've ever put out into space, and survive that passage, loops out, does another one. Solar shield worked as expected. Problem is that if we're contemplating a mission out to beyond the orbit of Neptune, every gram of material counts. And so a heat shield that would shield it from a close approach like that was found to be prohibitively heavy. So that kind of nixed that. So we thought, oh, well, at least we tried to figure out the possibilities. The other possibility that they've put out was to build a solar sail. A solar sail for a more direct passage out to Oumuamua, but energized. This borders, at least currently, on the verge of science fiction, because it would have to be a very large solar sail, and it would have to be energized by banks of lasers out in space. We're talking terawatt type of power out in space, so the output of a small nuclear reactor type of thing. We don't have any of those out in space currently. You want to look into that, Oscar? So while attractive, this type of approach, I think, is very workable, but it's certainly in the future for us. Just to build the infrastructure to fly something like this would be a decades-long effort, even if you had all the funding that you needed. It would require a lot of technology that we don't have just yet, and it's certainly advances in the technology that we do hold. The other proposal is, as opposed to one large one, and even in conjunction with this group is still thinking about approaches here, is to launch a bunch of very small solar sails in advance of a larger probe. And the reason for that is we don't know exactly where this thing is currently, right? We've tracked it as far as we could. It's beyond the reach of even the most powerful telescopes. We have a good handle on its trajectory. But if you're talking about trying to rendezvous something that's like a kilometer across out beyond the orbit of Neptune that you haven't seen before, it's certainly a shot in the dark. So what they propose is, well, you send out 1,000 of these small solar sails, and where you have high confidence that this thing must be, they'll photograph it, and then you can tweak the trajectory. Again, interesting thought, but well beyond our capabilities at this point in time. Certainly something we couldn't put together quickly enough to chase out Oumuamua. But then finally, actually, I should back up. That issue with the solar sails isn't that far-fetched, because for those of you that haven't heard of this, there is a project called Breakthrough Starshot. We have a bunch of billionaires interested in actually doing this, of sending, believe it or not, small probes out to Proxima Centauri, the star that Chuck mentioned there, by using solar sail technology. And with as opposed to Voyager, which will take 74,000 years, their concept is to, again, use microsatellites. We're talking about payloads on the order of a gram or two, but accelerating them with lasers up to a speed of 20% the speed of light. So in this approach, basically what you would be able to do is you could reach Proxima Centauri in, depending on the speed that you choose or that you're able to achieve, on the order of 30 to 40 years. The Voyageurs are still working, and they've been transmitting data for 45 years now. So we have the technology that has the longevity for that, and we probably have, or close to having the technology of circuitry that's small enough, because they'd want to put a camera and a sensor of some sort on something that weighs like a gram or two. So again, a lot of technological challenges, but we're at the point in our civilization and in our technology where we can even consider something like this as being plausible. So it's an interesting thought. So we've ruled out the light sail. We've ruled out the gravity assist from the sun. What this group ran was further simulations, and they found that by doing, again, a series of orbital maneuvers to pick up energy from close passage to planets like the Earth, like Venus, and finally Jupiter, complex series of these approaches, we could actually then slingshot by Jupiter and arrive where we think Oumuamua is in the year 2050. And that assumes a launch in 5 years from now, 2028. So interesting, and this would be achievable without the sun. We wouldn't need the sun shield, so that would save an enormous amount of mass. We could devote that to our instrumentation to study this thing if we found it, and it allows us to reduce the overall weight of the spacecraft, which means whatever kick we can get from our initial rocket burn off Earth, plus the assists from the planet, would buy us that much more velocity. So it is feasible with our technology to do this. Whether there's the will, whether there's the money, and whether there's the time to do it, that's an open question right now, but that pathway does exist. So interesting. As I said, this is the technology that New Horizons used on its flyby of Jupiter, or of Pluto, and it works. And this probe is still out there doing its thing. So this is what an artist's conception of what that might look like. A probe, something similar to New Horizons, flying by Oumuamua in the middle of this century. If that is, and I have doubts whether we'll see a mission like that launched. It would be nice if it did. In the meantime, on a related story, the European Space Agency has now funded and is building what a spacecraft called the Comet Interceptor, due for launch in 2029. What the purpose of this spacecraft is to enable us to have a spacecraft ready to chase down another object like Oumuamua or Comet Borisov if we see another one coming in. And I should have mentioned this before, with the various scenarios that we have in our theories of how planets are formed, there are estimates that there are literally hundreds of trillions of objects, asteroidal objects or fragments from the formation of planets wandering around our galaxy. So for many astronomers, we've expected to see something wander into our system for a long time. That concept isn't new. But we've just never seen anything like that until the advent of Oumuamua. And so what the Comet Interceptor will do, it's going to park itself out at the Lagrange 2 point, about 1.5 million kilometers away from Earth, and it's going to sit there for 3 years, just waiting. And if we see another object like Borisov or Oumuamua or something even different coming in from out, we'll be ready to press the button and say, go have a look at this thing. So it's not capable of reaching Oumuamua, but it is capable of possibly intercepting something that might be equally interesting. Oops, sorry, pressed the wrong button there. So in closing, a lot of questions about Oumuamua. We don't really know entirely what it is, as I mentioned. What we do know is it's really interesting. And if we could put a probe out to it, we stand to learn a lot about objects like that and how they fit into our current theories and models of planet formation. And just a final note on, and actually this just occurred to me on my way here today. In terms of an artificial origin, if it was a light sail or something like that, the light sails are only useful unless you've got a bank of lasers somewhere coming up your rear there and pushing your light sail. They're really only usable in realistic terms within the solar system, because they need a power source. You need a mega bank of space lasers, or they use the sun. If it's a big enough sail, it'll actually get enough energy transfer from the sun to push it around and make trips within the solar system a lot easier than they are now. So Oumuamua only picked up about 17 meters or something like that per second of additional velocity, and it changed its path. You think, okay, well, that certainly doesn't sound like a probe from with an artificial origin, because again, as Chuck pointed out, even the flight times at those velocities, even though it was moving at a good clip, are on the orders of tens of thousands of years to the nearest system. So for any kind of an alien civilization that might ponder that, they would have to be very different than us. Either they would have very long lifespans, or they become cyborgs, so they don't care about time. And I don't think either of those scenarios are likely. What occurred to me though is we haven't been able to observe Oumuamua for a while now, and I'm always asking, well, what if it was an interstellar probe? What about the thought of, if it's coming from really an advanced civilization, and it's a probe that's scouting around different planetary systems in this vicinity of the galaxy, a probe like that, if I was designing it, would have the ability to travel at, a good portion of the speed of light, because light speed travel, regardless of the level of sophistication of your civilization, is tricky. So even moving at only a 10th or a 20th or a 5th the speed of light has its issues, but they're probably not insurmountable. What I would think is that Project Starshot that I mentioned, if that ever came to pass, those little tiny solar sail spacecraft would sail through that system. They're not braking or anything. They would sail through that system in less than a day after traveling for 40 or 50 years. If I was designing something like this, if I was part of a civilization that had that capability, I would design a spacecraft that would travel at that speed of light, but then would also do some braking, so that once it's in the system of interest, it would have plenty of time to survey the planets with a sophisticated array of instruments. And then once it's done its job, or it's spending a few years in that system after traveling for God knows how many, after it leaves that system, would turn on its engines again, and away she goes to the next system. That's, again, far-fetched. It's just a speculation, but the fact is we don't know what's happened to Oumuamua. We don't. If it had afterburners and kicked them in out near Neptune, we wouldn't know about it. We just don't have the technology for that. So just one of those what if questions, but it would be really nice to actually see Oumuamua close up and glean the information that we can of this natural object, because it would only serve to give foundation and credence to some of the theories that we have about how this whole system, this galaxy of ours, works. So thank you for listening, including my babbling, and we'll leave it at that. All right. Thank you. All right, next we have our observation reports. We have a few, and we'll start off with Jim. And for those of you that are presenting type, maybe I can get you to stand ready at the wings there. Here's your button.
Greetings. Okay. So with this animation, I use the tone curve editor of the program IMPPG to enhance the surface detail of the sun so you could see the magnetic field patterns and plasma that's erupting from the surface. And notice how the field patterns change around the active regions. So this animation was captured with the Lunt 60mm H-alpha scope with a double stack attached. I use the ZWO ASI 174 monochrome camera with the program Fire Capture to take a series of 1,000 frames every 30 seconds for 70 minutes off the south balcony here in Ottawa, downtown, on February 26th. Thank you.
That's amazing stuff, Jim. That's beautiful. All right. Mr. Olson.
Big blue, big green.
Big green on. Yeah.
Okay. How do you do? It did occur to me that if this thing actually is manned or peopled, and we chase after it, is there any chance we start an interstellar war?
We know if they start shooting at probe.
Let's hope they shoot the probes instead of us. Okay, one more. Yeah. This is called the wild duck, or some, it's supposed to look like a flock of ducks or geese, and I've never seen that. When I stack my images, I use a plate solving of these images, and this thing has a mass of about 11,000 suns, and my plate solving used 8,000 stars. So quite something, quite a lot of stars in there. This is one of my favorite sights in the sky. I'd like to see it. You need a fairly large telescope, at least 8 inches or so to see it. And it's a very common target for imaging. It's about 51 million light years away, and it's found just under the handle of the Big Dipper. I have imaged this more than 90 times. So you guys must be getting bored with it, but it's a fascinating thing to see. This nebula is called the Iris Nebula, and the NGC number actually refers to the stars in the middle of it. It doesn't. But when I image it, I was much more interested in the blue nebula around it than I was in the stars in the middle. And it's about 13,000 light years away. No, 1,300 light years away. This is the Cat's Eye Nebula. It's about 18 million light years away. And in reading about it, I found that it's sometimes called the crocodile eye instead of the cat's eye. And it certainly looks a little more dark than a cat. Although I'm not a crazy cat person, by the way. So, when you see it like this, it looks like that thing that you used to feel or hear under your bed when you were 7 years old. Anyway, thank you very much.
All right. Nice stuff, Bob. Oh. Here you go. There you go, sir. Not too advanced. Yeah.
Okay, I only have one screenshot anyway.
Oh, okay.
So, but the laser is
The laser is, yeah.
just this big guy here. All right. All right. So, this is the coma cluster. It's a group of galaxies in Coma Berenices. It's one of my favorite objects to image. I've imaged it many times over the years. It's also known as Able 1367. What we see here, it contains so many galaxies on there that I can only show on this image a small portion of it. The field of view you see here is actually 20 arc minutes by 15, and that's it. So the actual cluster is larger than the size of the moon, actually. And the galaxies in it are about 200 to 400, between 200 and 400 million light years away, which is quite impressive. I shot this many times over the years. I tried 5 times on Sunday, and this is the best image of them. It was taken from my observatory in Orleans. It's a home observatory I've had for many years, taken with the Celestron Next Star 8-inch SE telescope with the Mallancam DX287C. That camera is a very low resolution, so therefore it makes very sensitive. There's no dark frame involved in here. There's no post-processing at all. All I've tried this time around was an old light pollution filter. And so it allowed me to boost the camera a bit more. No processing involved, except to shoot on the screen. We had to actually make it a bit to increase the brightness so that the faint galaxies would pop up a bit easier. So, this shot is actually a stack of 20 video shots. Each video shot is 3 seconds each, and that's it. So with 20 shots together, so it took about 1 minute to get this kind of image from Orleans. Also, the sky conditions were not very good at that night. That was taken last Sunday night. It was average transparency, average seeing, which means that some of the galaxies in there were hard to, well, the stars were hard to focus and made the stars like this one here a bit bigger than what it should be, and so is the little stars over here. What you see there is there's 74 galaxies on this shot, and every one of the arrows point to a galaxy. Being very windy in my sight also makes it hard to even stack some more, because all the stars, everything moves around, because after all, this observatory of mine is it's in the attic of my house. I decided one day, let's cut a hole through the roof and stick a scope through it. I've been using that setup for 22 years now, which works great. Magnitude range on this shot, you have a, where's the laser? Okay, you have a 11.4 magnitude here in this NGC. You got 11.8 magnitude here. And most of the other ones are in the range of 13, 14, 15. And there's a few little ones, very faint one like this one over here, I believe is around 17.8. Depending on the seeing and the transparency, we can, with the setup I have, I can actually see more. There was a few years ago, I saw 71 in that same field of view. But the problem is that if I go out of sight in a dark sky area, well, my setup can actually see down to magnitude 20, including Higgs and 50, that object that Jim Thompson showed last meeting. If I was able to capture all the galaxies in here, that down to magnitude 20, I could potentially see 120 galaxies in that field of view. So this is actually a very highly concentrated area. So there's a next challenge that I should try this in the dark sky. One last thing also, the cluster is so big, you would actually need to do a mosaic of 4 frames and stick them together to be able to see a good portion, well, the majority of the cluster. And with this setup in a dark sky, you could potentially have 250 galaxies show up in the same area. So if you want to get more information about it, I'll be around after the meeting, and I got more of these shots. Thank you very much.
Adam, we have Adam's online, right?
Can you hear me? Do you hear me? Not sure if I'm coming through on the audio there.
No volume, Chris.
Uh,
Hang on a sec, Adam. Yeah, just keep talking because we're.
okay,
Oh, I think we
yeah,
got
just
it.
let me know. Am I coming through now?
Yep, you're good.
Okay, great. Yeah, so hi, I'm a new member, and new to the hobby as well. I thought this was kind of neat though, so I thought I'd share it with the group. This is the telescope I used for my observation. Obviously, it was like done remotely through the internet. Hope that's hope I'm not going to get like kicked out of the club for that. It's the Green Bank 20-meter radio telescope, and it was built in the 90s as a science instrument. Then subsequently was defunded and acquired by an educational group called Skynet. And so I am able to access it through something called Skynet University, and I can share some details about that later. Yeah, it's so we could go to the next slide. Yeah, so this is a preliminary, this is the kind of calibrated data from a map of the Andromeda galaxy. And I just thought I'd walk through the whole thing because I thought it was like a neat process. So this is basically the radio telescope is it's a single pixel collector. Its beam is like, I think like a big fraction of a degree wide. And so what you do is you just sweep it back and forth to build up a bunch of overlapping data points. And then you can turn that into a map. And yeah, on the next slide, it's a cool thing. Oh, and also if you, the date and time on that observation, which is kind of cool, it was it was like 9:30 in the morning. And it was only maybe like 15 degrees away from the sun. So yeah, it's kind of neat. You can do the radio observations in the day. So yeah, so a cool thing also is that it collects spectral data. And so this was what's called an on-off sample. It's so it's like a sample from like the center of the target, and then one from a spot like maybe 5 degrees away in the sky, so that you can kind of extract the frequency specific to the target from like the background. And yeah, so this is showing the bumps here are neutral hydrogen lines, which is because of like quantum physics, a radio frequency that's emitted from cold hydrogen gas, basically like essentially hydrogen gas, and it's like ground state. And it's at 23 centimeters, and the big blip is hydrogen, basically like local hydrogen in the Milky Way. And then the kind of like spread out hump there is hydrogen from the Andromeda galaxy, which is blue shifted because Andromeda is like moving towards us. So these are the frequencies along the bottom are in megahertz. So it's blue shifted, and it's also spread out because Andromeda is rotating. So different parts of the galaxy are moving at different relative speeds to us. And on the next slide, what I did was, and I should mention, this was like kind of following like tutorials that are available through the organization that made this radio telescope available. So I'm kind of, I was just like following along. I did was slice the map into frequency bands. The green is kind of like the band at the middle of that hump for Andromeda. So it's basically like the average, the frequency of the neutral hydrogen emissions for the part of the galaxy that's like moving towards us in the center, kind of like the average speed of the galaxy. And then the red is the lower frequency part, and the blue is the higher frequency part. So it actually shows the part of the galaxy that's moving less quickly towards us and the part that's moving more quickly towards us. And the pink is neutral hydrogen from the Milky Way. So that's, it's much less blue shifted. And then in the final slide, I just annotated these different regions with kind of calculated radial velocity. So it came out for the average velocity of Andromeda. It came out actually really close. I think the real number is like something like 303 kilometers a second. So that's really close. But I think the rotational speed I got is around 140, 150 kilometers a second. And it's actually more like 200 kilometers a second. So but I did this kind of crudely. So I'll play around with it some more and see if I can refine that and get more accurate data. Oh, and then the Milky Way, this part of the Milky Way that we're seeing in this image, this gas clouds in the Milky Way are moving towards us at 5 kilometers a second, just because of where they are in the Milky Way. Thanks. Oh, sorry, I actually had one other thing I wanted to mention, which was just that, I've come across a few places that allow remote observation with radio telescopes and that have some kind of neat training stuff about radio astronomy. So yeah, I thought if anyone was interested, I just kind of wanted to pitch the idea of a group to kind of maybe get together and access some of those resources. I'll send an email out to the list and see if anyone's interested. Thanks.
Oh, thank you, Adam. That's rather unique stuff you got going there. Okay, Andrea.
I just want to say, I think that radio stuff is super cool, and I will go on the group trip, and I think we should have a presentation on that Skynet, which of course is a funny name. So I'm a little late presenting my observations. This was that beautiful and really, really long lunar eclipse we had in March. These were one of the like 800 pictures I took of the total phase, which lasted almost 30 minutes, which was crazy. And what I wanted to sort of demonstrate, obviously we'd mentioned this last month, how there was always a little bit of a glow and it kind of moved along the moon. So even though it was supposed to be a total lunar eclipse, I took these photos without a telescope. I just used a regular camera and a long telephoto lens. So you do not need fancy equipment to take photos that are beautiful of the moon. There's like this weird beeping. Does anybody else hear the weird beeping? Yeah, it's something to do with the mic, but I'm going to stand here. I think it's better. Yeah, it's as soon as I speak. So basically I used a star tracker though. So I did use a telephoto lens. It was 560 millimeters and I had it on a star tracker. And why you need a star tracker is if you are really zoomed in and you are only on a tripod, the moon will move within 1 second. These were, at one point, I had 6-second exposures of the moon. That's how dark it got during a total eclipse. But because it was on a tracker, I was able to maintain sharp images for 6 seconds. So that's kind of the trick if you want to do total lunar eclipses. Get a star tracker. They're not very expensive and they're very helpful. And any regular camera with a 400 millimeter lens is good for the moon. And why won't you move forward? What am I doing? Oh, there we go. And this was just another picture of the eclipse. I just thought it was so pretty with the stars all coming out in the full moon. I eventually am going to make a whole little lineup of all the partial phase, but I never got to it. I was fortunate to travel to New Brunswick at the end of the month, and I saw the partial solar eclipse, but I'm not going to show you all my images because I'm going to talk about it July, I think. I'm going to do a bit of a presentation on how I shot the solar eclipse from New Brunswick. But this was just a really fun shot where the bird came flying out and I managed to catch it because I was down by the Bay of Fundy. Now, these are some of my deep sky photos. I take these with a big telescope and an astronomical camera. This image was a stack of 3-minute exposures for 2 nights. So all night, so like 12 hours with a monochrome camera. This is, I originally wanted to take a picture of NGC 3718 located in Ursa Major. And I didn't realize there was a little friend nearby, NGC 3729. These are approximately 65 million years ago. And it's believed that they are close enough that they are actually interacting. And that's why NGC 3718 is all twirly and weird. And in the image as well is a very small Hickson compact group 56. And it's a little tiny galaxy grouping 8 times further away. So do the math. And finally, I did some images, and this is with a color camera because I was doing something with the other camera and then something terrible happened to my telescope. But this picture turned out okay. And it's M63, the sunflower galaxy, and named because the center looks a bit like a sunflower. Again, all night long, 6 hours of 3-minute exposures. Canis Venatici, 25 million light years away. That's the end for me. So who's next? There.
Thanks, Andrea. Nice stuff. Okay, I just have 2 images of the moon. This was in response to the challenge object, which is Mare Austral, which is down there. This is a mare like the other ones that are much more familiar to everybody, but it's right on the edge of the lunar disk there, and you can only see this at times of favorable libration when the eastern side is tilted a bit more towards us than the other times, because when it's not tilted, when it's tilted the other way, this is actually on the back side from our point of view here on Earth. So it is a bit rare to see, and I've got the only other image I've got is a bit of a close-up of the same, and you can see it. There we go. There's the Mare itself, and we've got a couple of craters, Oken and Layout, that are right near the Mare Austral, who've had their floors flooded with the same material that the Mare itself has, giving them that dark color. And just for reference, that is the crater Tycho. This was done at an almost full moon there. We had a bit of libration, favorable libration on the southern portion of the moon there. So you can see down around the terminator there that even though the rest of the moon seemed quite full, those areas are still receiving are still at an angle where they see some shadow play. And so you can actually see the detail. It's actually my favorite technique nowadays for trying to image things like mountains and craters that exist near the terminator or near the rim of the moon. That's it for me. And Richard.
So here's my observations of the challenge objects this month. The constellation was Coma Berenices, and I was taking pictures at the night of the full moon. So that's why the sky literally was a blue shade. You could see it a bit with your eye, with the camera taking about 6-second exposures. The sky was blue from the full moon. But through the magic of stacking and processing, I did manage to pull out the stars of Coma Berenices at that time. The constellation is pretty dim, and usually you just see an outline of 3 stars. It'll be hard for me to see on here. That one, that one, that one. So those are the three stars generally shown in the outlines of the constellation. But the thing that I really like about this is that there's this tuft of hair up here, which I guess is what they call the coma is a word for hair, and Berenices was one of the queens. But it really is more attached to the end of the lion, Leo. That bright star on the right edge of the photo is Denebola, the last star in the constellation of Leo. But there is a kind of line, if I go back, you might be able to make out a kind of curved line of faint stars in there. And then this tuft of stars, Melot 111, is an open cluster. It's very large, and it is visible to the naked eye. I was out at FLO this month, and you could definitely see a little fuzzy patch in the sky there. So I think that was the interesting part of the constellation. Now, zooming in on that cluster, it's too big to fit in my field of view. This is the largest field of view combination that I've got. My Z73 refractor with my new 2600 camera, and it's still too big to fit the entire cluster in. But it is a very nice cluster of sparkly stars, lots of different colors and so on. Now, the next challenge object was the Galaxy M100, which is a beautiful face-on spiral galaxy with a nice edge-on spiral close by. But it's very nice to see these definitely curved arms, and they're much brighter with relationship with the core of the galaxies than some of the others we've seen. So this one was also with my Z73 refractor, but this time I used the 178 camera, which has a much smaller field of view, and it essentially magnifies things quite a bit more. And then I also have, like Denis Legault, the Coma cluster of galaxies back to my big frame camera, and this is quite a large cluster, and it's a large field of view here. And when I tried processing it with PixInsight, it has an annotate feature where it can pull out the positions of known galaxies from the principal galaxies catalog. In this frame, which I think is about 3 degrees by 2 degrees, it identified there were, what was it? 1,266 galaxies. I did not show the image on here with all the labels because it just overwhelms the whole picture. But if you want to go on the Discord server, I've posted a copy of it there. And when I actually looked at the points it was identifying as galaxies, in almost every one, there was a little dot of light there. Sometimes definitely fuzzy, definitely elliptical shaped, and in some cases just a single spot. But there are just literally thousands of galaxies in this galaxy cluster. It's a really wonderful place to explore. And thank you, Paul, for your picture of the full moon. I was taking pictures during the, just bit before the first quarter phase. And actually the libration was even better at this time. And you can see a bit more of my Astral. But you can see the libration changes even within a few days. So here's my close-up view, and you can see that the craters Oken and Lyot are more round, so they're farther out into our field of view at this point, whereas by the time of the full moon, just a week later, they were more on the edge. And then, of course, they'd be disappearing after the full moon because the shadow would come over. So the libration of the moon is something that's quite interesting to monitor just within a single lunar cycle of 1 month. and it will change over the year as well. This particular time of year is really good for seeing the southern parts of the moon because the moon is so high in our sky. Okay, so those were the challenge objects for this last month. Thank you for the other people who participated. We've got lots of pictures on the Discord server. Mark Lilienthal had a nice view also like Paul's of the full moon. Xavier and Mark got the M100 on April 25th. There were some high clouds that night, but you could see the galaxy quite well. And we've just seen Denis Legault's image with his 74 galaxies identified. So next month, another faint constellation, the constellation of Draco. It's nicely positioned at this time of the year in the eastern sky and overhead. The tail of Draco is actually right between the two dippers, the Big Dipper up here and the Little Dipper down here. So there's the tail of the dragon, and it curves around the Little Dipper and then back over here where the head of the dragon is right beside Hercules. So it's a very big constellation, but it's fairly easy to see. If you can see the Little Dipper, you can generally see Draco as well. It's not great from Ottawa, but certainly I was watching it from FLO on Sunday night this last weekend. Now within that, the next level challenge is a binocular object that again I was seeing from FLO, and I don't know if it has a name. I haven't seen it marked on any map, but there is a little curved arc of stars, all about the same magnitude, fairly faint, but quite easily visible in binoculars. And in fact, there's another one here, a little bit brighter and not as distinct, but it kind of makes a kind of two half circles almost around a central star there. So quite an interesting little set of stars to look for in binoculars. For the level 3 challenge, also in the same area, is a very interesting barred spiral that's sort of slightly tilted, more edge on like Andromeda. And that is in that same area here, but you will not see it in binoculars. It is quite a faint galaxy. It's very big, and for imagers, it should be no problem to capture it, but it's not easy to see, certainly not with binoculars. Maybe with a big telescope, you could see that one. And then for the level 4 challenge, we have NGC 5982, which is a small elliptical galaxy. But the really interesting thing about this one is that it's in a cluster of 3 galaxies, all very close together. So NGC 5982 is an elliptical galaxy. On one side of it is a beautiful little spiral galaxy. And on the other side of it is a nice edge-on galaxy. So you've got 3 very distinct types of galaxies, all within the same very small field of view. So I think that will be an interesting one for people to take pictures of as well. And for the lunar challenge, the solar system challenge, this is something that I haven't really noticed very much before, but it's quite distinct around this time. So if you're out at Astronomy Day tomorrow or at FLO on Sunday, see if you can take a look at the moon and look for an extra rim of Mare Nectaris. It's in the southern part of the moon, right near the terminator of the first quarter here. And it's in all of the craters and mountains of the moon, but it forms a kind of extra semicircle around the side of Mare Nectaris. So let's see if people can have a look at that as well. So those are your challenges for May. Thank you.
Thank you, Richard. All right. Public star parties. Yeah, it is that season. So Andrea is going to talk a little bit about public star parties and then we'll wrap up.
Told you I'd be back. I'm here because Deepinder, our Star Party coordinator, couldn't be here tonight. But they are starting this month. These are the dates. So the first one that's coming up is May 30th. The second day is Thank you. The rain date. And normally on the Friday morning, there's a no-go decision whether or not to proceed on the Friday night or the Saturday night. And they are at the CARP Library parking lot. You don't park by the library. There's a parking lot next to it. The public arrives when it gets dark. In May and June, by that time, it doesn't get dark until quite late. If you are coming as a volunteer with your own telescope, come a little bit earlier so you can set up with it when it's still light out. If you are a member and you want some help, let us know in advance so we can get ready and maybe help you with your telescope at the Star Party. There is also a web page on our website about star parties. Do not bring green lasers. I think we've covered that. We also sometimes need traffic control. So if you're a volunteer who just wants to come look around but not have your telescope, you're very welcome. And we appreciate anybody who can come and help and who wants to come and learn as well. And I think that's the new thing he designed. And Deepinder also designed a QR code that is very cool. And that's not me, so I'll stop now. Okay, thank you. So he'll call out and you let him know if you can come a little closer to that date.
Thanks, Andrea.
Sorry.
Oh,
I just want to, I did read also, Rick is doing his FLO orientation daytime this Sunday, Star Wars Day, between 2 and 4 p.m. He wants you to email him if you are going to come, and he'll, the email, you should have the email. Thank you.
thank you. Oh, bug spray. Bug spray recommended. Yes, they are starting to come out with non-DEET. Okay. I won't ask why, but all right. So just going to wrap up here. Just a quick review of our site here, or a quick look at our site there. This is the Fred Lossing Observatory for those that haven't been out. This is open to our members, and you, as a member, you have access after you receive the appropriate training to any of the 3 big scopes that we have out there, or you can bring your own gear and set it up. We have quite a nice sized open area there where you can set up your own gear on the mound up near the big scope, the 18-inch, and also closer to the other 2 scopes as well. So those are available. We actually just mentioned the FLO star. Well, we mentioned the star parties. These are not the public star parties. These are ones held at FLO. The next one is scheduled for May 24th. Those are for members only. Estelle's pick of the month. This is a classic, Night Watch, by our dearly departed friend Terence Dickinson, and also Ken Hewitt-White. For those of you new to astronomy, this is an excellent reference to get your hands on or to look through. Club information, as mentioned, Rick is our FLO director. Estelle is our guardian of the books. Peter Shute runs the equipment loan library. If you're interested in borrowing a scope, please contact him. And for membership inquiries, Art Fraser is the guy to talk to. Okay, tonight we had 54 members here and 40 on Zoom, so a total of 94. And I just want to extend thank you to everybody that contributed time and effort and images to our meeting tonight. If you have ideas for our talks or observations that you want to submit, there's my address, meetingchair@ottawa.rasc.ca. Please feel free to contact me at any time, or just with any inquiries you might have about what goes on here at the meetings or other things, and I will attempt to help you or direct you to the person that can. Okay, for those interested, we have our informal after meeting meeting at Liam McGuire's down at 1705 Saint Laurent. Yeah, they keep the fries coming and the beer cold. So next meeting, June the 6th, and that's Friday night of next month. And just a note that we will be running a swap table on that, which again, for those of you not familiar with it, we do this, we're going to try to do this at least twice a year. If you have gear that you're no longer using that you'd like to sell, so you can afford new fancy gear, bring it on. Bring it on. We'll have tables set up here, and we'll do the meeting. Just thinking about the meeting time. I don't want to jiggle around things too much, but we'll leave a bit of a 15 or 20 minutes on either side of the meeting for you to look around at the tables there and make a deal if you're so inclined. So do feel free to participate in that. And that's it for tonight. Hope to see you next month. Clear skies to everybody, and stay well. Night. Good night. Yeah. How's it going? Yeah. So you started it. Yeah. Oh, that's your official. Okay, right. Right. I wasn't sure whether I knew it was, Monday or Monday. Well, good. Monday was the election.